Alkhowarizmi's students actually came up with something called the Sijistani Society in 970, and that society was a group of learned males. Again, the females aren't being educated that much unless they're being educated in the home, but that would be about it. But this was a group of men who would get together and write manuscripts, or what they called epistles, and they gave scientific explanations for things. And so they were writing about tides and earthquakes and sound waves. Somehow they had discovered the concept of a sound wave. So they had a lot of treatises that they wrote by the 10th century. The most important one was their one on mathematics. And they wrote, in terms of mathematics, they opened up their book on math by saying the science of numbers is the root of the sciences, the element of wisdom, the origin of the divine sciences, the pillars of meaning, the first elixir, and the great alchemy. So what you're seeing here is a link between mysticism and mathematics and science. So a number is not simply a number is also a symbol. The number is sort of a pathway into understanding creation. That if you want to look at creation, you can deconstruct it through numbers and mathematics and rhythm and unity and all the stuff that ends up moving right into art and architecture as well. So this is actually the Dome of the Rock, which is in Israel. And one of the things that I liked about this book that the Sijistani Society wrote, or the Brethren of Purity is what they changed their name to eventually, is they called mathematics the tongue that speaks of unity. And I thought, there you have it right there in terms of a visual representation of unity and mathematics and rhythm and mysticism. Also, the Quran talks about symbolism. So this sort of link between mysticism and math and science is actually supported by the Quran. Chapter 14, verses 29 to 31 says, "Hast thou not seen how God citeth a symbol? A good word is like a good tree. Its root is set firm, and its branches in heaven, giving fruit at every season. So God cites symbols for men so that they can remember." So there's an encouragement to look at things as symbols. And of course, number one was the big symbol in terms of unity, the one God, Allah. It's actually, number one is often referred to just as the source. And I don't know how much you guys cover the 7 liberal arts in your classes, but one of the things that happens in European curriculum, university curriculum at this time, is something that really started in Greece called the 7 liberal arts. There's the quadrivium and the trivium. That's reintroduced into the curriculum through the Arabs and through the Muslim scholars and through the scholars that are supported through the Islamic centers of learning. And the quadrivium is all very, very, very mathematical. So that you've got arithmetic, which is considered pure number. You've got geometry, which is number within spatial relationships. You've got music, which was considered a science, a mathematical science, because it is number in time and rhythm. And astronomy, which is number in terms of their relationship of time and space. And then trivium is grammar, rhetoric, and logic. So a well-rounded person did both the quadrivium and the trivium in terms of their education. One of the things that I wanted to talk about is when I first looked at this, I actually went to the Dome of the Rock, and when I looked up at this, I actually, when I looked at the slide of it later on, I started looking at it, I thought, okay, so what is this structure saying? To me, as a Muslim, what's it saying? And I looked at it and I thought, okay, there's no beginning and there's no end to this, so there's infinity. There's harmony through rhythm and mathematics. Then I remembered the tongue that speaks of divine unity. There's multiplicity as well as unity in the created world. I looked at the center of it and thought that's really a symbol of the center right there. And as you move closer to the center of divine reality, things start getting closer and closer. All paths are leading to the same truth, the same center. It reminded me of some of the Quranic passages about stars as guides, because there were sort of some white speckly parts there, and I thought of stars. There's verses, of course, God is as the guide and God as the light. And then I started thinking, is there anything in this list that you cannot find in Christianity? I thought, no, not really. So as you're looking at Byzantine art, you're seeing very much of the same thing. When you're looking at Byzantine architecture, you're looking at the sort of mystical use of number, rhythm, harmony, unity, etc. Back to mathematics, too, I wanted to talk about India's contribution, because one of the things that, actually 3 of the things that they gave us in terms of our mathematics is the concept of zero, the concept of a void. And when you're talking to your students, tell them try to write 204 without using a zero. You can't do it. And so that idea became pretty revolutionary. And the idea of a numeral, this symbol that represents a 4 or a 6 or a 9, was very revolutionary. Because one of the things that's kind of fun, also, there's place values. They have the ones and the tens and the hundreds and the thousands. That all came from India. And so we call these numbers the Arabic numerals, but they were really designed in India. And one of the things that's kind of fun is just give a really easy math problem to your students and just say 7 times 12 divided by 13. And they all think they're very cool, and they pull out their little pencils and they start, and you say, no. Do it with Roman numerals. Say you're not allowed to use Arabic numerals. You have to use Roman numerals. And they can't. So that gives you an idea of how revolutionary this whole concept was that was coming in from India. One of the things I want to talk about with math is Algebra and Alkhowarizmi, two very important people. Can you figure out what word comes from Algebra? Algebra, that's the root of our word algebra. And then there's another word that comes from Alkhowarizmi. Algorithm. Yeah, so these two people, their names have been anglicized or Latinized, I guess, into words that have to do a lot with math. Algebra was a person who wrote a book called he wrote a book on mathematics. I can't find the title of it here. The Book of Restoration and Opposition. That was the title of it. But the word jabr in Arabic has JBR as its root. And that goes into both bone setting and it goes into restoration. And when the students, they kind of crinkle their faces when I say bone setting. I say, well, when you're setting a bone, you're putting things in the proper order. They're not in the proper order, but you're returning them to the proper order. They're off. And you're putting it all back. And so then it suddenly made sense to them. But he developed the idea of geometry and trigonometry and decimal points. So he started adding things to what the people from India had brought in. Alkhowarizmi is a 9th century mathematician, and he ended up becoming the most widely read mathematician in medieval Europe ever. I mean, he was the one that was sort of the person sort of kicked off math in Europe, Alkhowarizmi's books. He was a librarian at the Beit al-Hikmah, or the House of Wisdom in Baghdad, and he ended up working on the project to define what is 1 degree of the Earth's surface, and the Chinese had already figured that out. There's 360 degrees to the Earth's surface, and they have how long is 1 degree. And the Chinese had figured this out already, but he did it with them as well. And then his name again was Latinized into algorithm. One of the things that I also talk to my students about is the fact that there's a link between religious practice of Muslims and mathematics and astronomy and time and the links between time and math. Why would Muslims be so strong in mathematics, the early Muslims? I mean, this is calculation we're looking at. What are they calculating?
Position of the sun, the
prayer. Exactly, prayer times. Yep, you have to calculate your prayer times. You have to calculate the fasting dates. You have to calculate, you can't text somebody and say, is Hajj this week? You can't do that. You have to calculate it and say, when's Hajj? When are the prayer times? When is fasting? Also, it links into geography as well. So if you're supposed to be praying toward Mecca and you're in China, you better know what direction Mecca's in. Or if you're in Italy, you better know where Mecca is compared to Italy. So the Muslims sort of zoomed ahead of everybody else in terms of math and geography and astronomy because of this. There was another person by the name of Tusi, a 12th century mathematician, who came up with something called Tusi's couple. And that's a picture of it over here. And it's actually talking about if you have this thing spinning, an outer circle spinning, and the inner one spinning, how is it going to move on this? And then it actually starts to look at this point as if it's going backwards. And he figured out that planets, he started to figure out planets going into retrograde, is what he was doing with this one. And Copernicus, who's 16th century European scholar, was actually credited with figuring this out. He wrote a book called Concerning the Revolution of Heavenly Bodies, but it was basically a repeat of what Al-Tusi had done in the 12th century.